problem, we're going to deal with some unfriendly fractions like ninths and eighteenths. In order to solve these, we're going to use the clock model, but fortunately there is a way to deal with these fractions with the clock. So what I would say is that here we have 2/3 and a third. Well, if you have 2/3 and a third, we have 1 whole hour. Right? 2/3 is like 40 minutes, brings us all the way here. Every third is 20 minutes. 2/3 is 40 minutes, brings us here. Another third is another 20 minutes. 40 and 20, that's an hour, excuse me, or 1 hour. Now the second problem, before we rush and say, oh, I don't know what a ninth is, you might recognize that this is just like 1/3. Right? Having 1 out of 3, same thing as having 3 out of 9, just with more numbers, right? But ultimately, 3/9 does reduce to 1/3, so this is still just 2/3 and 3/9, and that's 1 hour. But if we forgot that, if we weren't given this string, you could always try and see that connection between 3/9 and 1/3. So what is 3/9? 3/9 is equal to 1/3, which is equal to 20 minutes. Okay. So what does 1/9 equal? Let's try to tackle that one. Well, what's the connection between a third and a ninth? Well, if you have, where can I draw it? Well, let me draw it over here. If you have some piece of, I don't know, cake or something, and you gave out 3 pieces, right? You would cut the cake into thirds, and everyone would get one of those thirds of the cake. But ninths are different. It says, if I cut this cake into 9 pieces, right? 9, this is supposed to be equal pieces, sorry about that. 9 pieces, everyone will get a ninth, right? This is me handing out the cake to people, these lines down here. So these little pieces now are 1/9 of the total cake. So what's the connection between thirds and ninths? Well, thirds, right, here is 1/3, here's 2/3, here's 3/3. So a ninth, if you can see this little orange piece compared to the blue, a ninth is 1/3 of a third. It's 3 times smaller than a third, right? It takes 3 of these ninths to make a third. So what does that mean? Well, a ninth has to equal 20 minutes divided by 3, right? Because 20 minutes represents a third, and a ninth is 3 times smaller. So we take what a third is, 20 minutes, and divide it by 3 to get the ninth, to get 3 times smaller. So what's that? Well, 3 goes into 20 6 times. And what's left over but 2 out of 3? So 6 and 2/3. Notice that's not friendly. This means that a ninth is equal to 6 and 2/3 of a minute. But 3/9 works out really nicely. That gives us 20 minutes altogether. So anyways, I wanted to show that. I hope I didn't confuse us too much there. But now we know what a ninth is. And you see that isn't that friendly with the clock model. But we can still use the clock model to understand that a ninth is really equal to 6 and 2/3 minutes. And you might not like that, I understand. But moving on. 5/6. Well, every 1/6 that we talk about in other videos is just 10 minutes. So it's 50 minutes plus 3/18. Well, here's another fraction that seems nasty, but you might recognize that equals 1/6 or 10 minutes. So altogether, this is equal to 1 hour, right? This is really just like 5/6 and then 1 more sixth. Now, 18ths are related to 6. We know that 3/18 equals 1/6, which gives us 10 minutes. But, I should put an hour down here too. But, what does 1/18 equal? Well, 1/18, just the same reasoning here, is 3 times smaller than a sixth. So if a sixth equals 10 minutes, then an 18th is 3 times smaller, so we divide by 3. And that's 3 and a third. What does that mean? That means every time you have an 18th, you have 3 and a third of a minute. Still not a very friendly or useful fraction, but fortunately, when we have 3/18, we just go back to sixth. So you can think of 18ths on certain occasions as if they were sixth. So that helps. Okay, moving on. Now we have, again, the mixed numbers. It's 4 hours. And 1/6 is, again, 10 minutes. And this is, well, 6 goes into 24 how many times? If we divide 6 by 6, we get 1. Divide 24 by 6, we get 4. This is like 1/4 of an hour, which gives us, that's just this part, which gives us 15 minutes. So this is 15 minutes and 10 minutes. It gives us 4 hours and 25 minutes. And you correct that as a mixed number. 4 and 1/4. Because, oops, what am I saying? 4 hours and 25 minutes. How many times does 25 go into 60? Well, not an even amount of time. So I'm just going to write it as 25 over 60. So that's 4 hours and 25 out of 60 minutes. And last but not least, we have 6 hours because we have 3 and 3. And then we have a sixth, which is 10 minutes plus 20 over 25. Well, if we reduce this, here we encounter the 25ths, 25ths of an hour. If we reduce this, we can say that 20 divided by 5 is 4. And I'm simplifying this fraction. And 25 divided by 5 is 5. So now we have fifths. And we talked about this in other videos, but every time you have 1/5, you have 12 minutes. Because 12 goes into the clock, the circle, 5 times, right? 12 times 5 is 60. But that means that 4/5 is like having 4 groups of 12, or 48 minutes. So that brings us to this. So 6 hours, 10 minutes, and 48 minutes. We can write that as a mixed number. 6 hours and 58 out of 60 minutes. And just, even though this is not very friendly and the clock model isn't like stunningly helpful here, it does remind me that the reason we're doing this and all this tedious work is to stay with our intuition. Notice how when I solved this, I didn't use an algorithm where I just changed denominators and blindly followed through, but reasoned through what this problem is. And I might have made a mistake. Who knows? I mean, I'm not going to go back and check right now. Hopefully I didn't. But at least I'm trying to reason through this problem. It gives me some intuition as to what answer actually makes sense. All right, more to come.